Okay, let's try the next two questions. It says here we're working with the same graph of the derivative. Write down the x-coordinate of the point of inflection of the graph of g. Well, that's just a matter of understanding. You know that the understanding this derivative function when it's graphed, we know that the x-intercepts are the turning points, but the turning point of the graph of the derivative is always the point of inflection. So we know that it's going to be right in between 6 and minus 2. And we know that it's in the middle of this just by symmetry. So minus 2 plus 6 divided by 2 is 2. That's the easiest way to do it. But hey, you could get this 2 in different ways. We have the equation of we could figure out the second derivative. Just take that derivative that the equation, take the derivative and the second derivative, make it equal 0, and find that x equals 2. I think that's kind of a hard way to do it. You could go, hey, this is a parabola. I've got the equation of this parabola, this derivative, and all I have to do is go minus b over 2a. And that would give me 2 as well if I've got the equation of this derivative. I should have written them down. But there's, hey, 3 different ways you could do it. There's the easiest way. The next question, it says, explain why g has a local maximum at this. Why do we know that's the local maximum? Well, the first way is just with words. We know the gradient's positive, it's increasing. We know it's 0, and then we know it's negative. You just write down, it's increasing, it's 0, then it's decreasing. Therefore, g's got a local maximum because it's increasing followed by decreasing. But you could draw a picture of it. You could say, well, that's exactly what it has to look like there because I know it's greater than 0, increasing on one side and decreasing on the other. You could draw a picture of it. Or you could go back to our very original, I get all these are different ways from the memo of doing it. Go back to our original way of doing things. There's the sketch of the derivative. This is, if you can show that, oh, this is what the graph looks like, and they're both minus 2 here, g has a local maximum minus 2. That's demonstrating that you understand. It's like you're able to put one graph on top of each other, or you can compare the two. And there you go.